I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover the Deprecated Functions, Identify Functions activity. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training, and additionally, that you've completed the Requirements Taxonomy, Security Requirements, Secure Design Principles, Apply Secure Design, and Secure Settings trainings. This training will cover deprecated function identification. Before getting into deprecated function identification, let's briefly review where it fits in the overall deprecated functions process. Here's the deprecated functions process, which we've previously covered in the deprecated functions overview training. Our focus for this training will be on the first activity, that of function identification. Within the function identification activity, the cybersecurity SME takes the authoritative sources and identifies the deprecated functions called out in them, creating a deprecated functions list. From this list, an identified deprecated functions report is created. An important aspect of dealing with deprecated functions is that of the authoritative sources used as the basis for identifying them. These fall into broadly three groups. This is not to say that these are the only sources where we're going to look. However, it's important to have, as with all things we do in cybersecurity, appropriate traceability. And so that's going to guide the kind of sources we look to. And although they may be interesting, ephemeral sources are not all that useful. We want durable sources. Looking toward things which are AI generated is not going to be something that we can go back and replicate easily. Now, the first group we're going to consider is that of technical standards. These are things which come from national and international bodies such as ISO, BSI, ANSI, or NIST. Here we see ISO IEC 9899. This is the standard for the C programming language. Yes, there is a real written standard. Within this standard is an annex which covers unsafe functions. For our next group, we have best practices. For our example here, we have the SDL list of banned functions from Intel for the C and C++ programming languages. This list conveniently provides us with alternatives to use, and we'll talk about that shortly. Most large organizations which produce development software will have some publicly available set of guidelines that they use for doing software development covering various languages. The functions which have been deprecated will typically be covered here. The third group is that of industry recommendations. Typically, these are associated with life cycles, providing restrictions on what language versions and functions are not appropriate for use within a specified context. Here is MISRA C++ 2023, Guideline for the Use of C++ 17 in Critical Systems. It's typical of the recommendations we find for safety-critical systems. From these sources, we're going to extract the information that allows us to go from functions which are deprecated to ones which are more appropriate. Now let's work our way through an example of deprecated function identification. We'll be using the AVCDL deprecated function catalog template, which is described in this training's accompanying tertiary document. It's important to note here that this is just one mechanism for documenting this information. There are any number of ways this information could be documented. In an ideal world, you'd use a database to store the information across various languages and platforms. In this example, we're going to look at the C++ language, running on Linux. Including the platform here is important because there are going to be deprecated functions which may be operating system specific. There's no point calling out functions which don't have applicability to the operating system or the language that we're targeting. This is especially true when we're looking at things like static analyzers, which may be able to take the deprecated functions list and scan for it. if we're only targeting Linux, but we're looking for deprecated Windows functions calls, all we're doing is consuming resources and time. Next, we have the cybersecurity SME who performed this activity, the date, and the revision, which is a monotonically increasing number. Next, and arguably one of the most important things to document, is the references that were used to compile the authoritative sources and the replacements. We capture three pieces of information. The first is the name of the source. The next is its description. This is included because the name isn't always sufficiently clear. And finally is its location. This piece of information brings us back to why we may have to revise this document. For some sources, the location won't be subject to change. Other times, such as when we're pointing into repositories, things may move, and you'll need to update the location information accordingly. The first three entries are authoritative sources. Looking at the Microsoft banned functions, we have a page describing the banned Microsoft Security Development Lifecycle functions and its location. We have a similar case with the Intel banned functions. The last three entries are references to the replacements for those deprecated functions. It's just as important to provide references to the replacements as to the authoritative sources, because you need to know where to look to find the pieces that you're going to be replacing things with. It's not sufficient to just collect a list of what's deprecated. In the template that's provided is a category sheet. The intent is that you either rename it to deprecated functions and put all of the functions there, or create separate sheets grouping like functions into categories and renaming the sheets appropriately. In the case of the example that we're using, within the context of C++, 4 categories were used. These are formatting, memory management, string handling, and time-related functions. Let's look at one of these in detail. The formatting sheet of our example shows the typical way that we're going to be recording the deprecated function information. We're going to have a unique identifier for each of the functions identified, the deprecated function's name, the header that it's in, the reason for the deprecation, and this is really important. It's critical to provide why this needs to be replaced. Next is the suggested replacement. It's not enough to say that this function is bad for whatever reason, whether it's that the feature of the language has been removed, that the function is considered unsafe, whatever the rationale behind it is, having a means to replace it that's clear is really important. And finally, a notes column. The functions within this category fall into 2 buckets, those related to input and those related to output. As you can see, the reason for deprecation for those related to input are all the same, and that's to be expected since these functions are all in the same family. We also have similar reasons for deprecating the functions that are related to output. Looking at the suggested replacement, one of the key things shown here is that we're not just considering the latest and greatest version of the language that we're dealing with. In languages like C++, which have been around for decades, there's a lot of growth that has occurred, and because of that, over time, limitations that were recognized have been addressed in different ways. As we see here with DFF05, the VSPrintf issue, our suggested replacement when we're dealing with C++ 20 and later is standard format. If all we have is C++ 11 or later, then we're going to recommend the format library that eventually became standard format. And otherwise, we're recommending that an O-string stream be used. It's important to recognize that not all replacements are going to be equal, and that sometimes, as in the case of standard format versus streams, there's going to be a distinction in performance and other characteristics. This is a trade-off that has to be made by the development teams based on the criticality of the code. Sometimes there is no fast and safe alternative to a function that needs to be replaced. Now let's look at the notes column. As you see, they're just numerics. What we've done within this example is provide references to the authoritative sources so that people can look them up. As we can see here, these are sourced from multiple locations. Additionally, since they're also provided in the references, you could provide notes that tell you which references were used as the basis for the suggested replacements. In this example, the sources of the suggested replacements are unambiguous. With the deprecated functions, we don't know where they're being sourced from unless we include a reference. Now, the treatment for the other groups that we had is going to be the same as what we've done here with formatting. That covers deprecated function identification. Let's review some of the important points. When identifying deprecated functions, focus on a single language on a single platform. Document the authoritative sources, provide clear reasoning as to why the function should be replaced, consider solution alternatives for variants of language and configuration, identify where the particular deprecated function is being sourced from, and generate a human-readable report when it's done. That way, you'll have a summary of all the actions that you need to take. The materials that were used to cover this example are in the location shown here. It's important to note that the workbook includes all of the sheets covered in this training. For additional information and to get a more in-depth set of references, the Deprecated Functions Identify Functions Procedure tertiary document is available in the AVCDL GitHub repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. With this training complete, if you've completed the other trainings covering the deprecated functions process activities, you can proceed to the other trainings at this level. These include code reuse and secure coding. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL GitHub repository.